All right, so we're going to focus now a little bit more. Instead of just talking about polygons that are similar, we're wondering, are triangles similar? And if you remember, triangles are kind of like the basis of a lot of our other shapes. So if we can show that triangles are similar, that goes a long way to maybe proving some other shapes are similar. So we want to focus on these. And the nice thing about triangles is, just like when we were trying to prove that triangles were congruent, there are some nice shortcuts we can use. So instead of having to show that all of the angles are equal to all of the angles in the second shape, and all of the sides are proportional to all of the sides in the other shape, for triangles we have some shortcuts. And so here's the three. Well, I think there's three shortcuts that we're gonna see for similarity. So your first one is what's called angle-angle similarity, which if you notice up here, there's kind of a shortcut way of writing it. Right, we have this notation, AA stands for angle-angle. Just like when you did triangle congruence, you talked about sides, and we used SSS. Similar kind of thing. We're called AA for angle-angle. And then I'm using the similarity symbol to replace the word similarity. Right. So here's what angle-angle similarity is saying. If you can prove that in two triangles that the corresponding angles in one, two of the corresponding angles in one are congruent to two of the corresponding angles in the other, that's enough. We don't even need to look at the sides, right? So in this particular example here, if you notice, they're showing us that angle S is congruent to angle M, that R is congruent to L, and that's it. We don't know anything about the sides here. But what we're going to be able to say for sure is that these triangles are similar. So I know that if you set up SR over ML, and you got the fraction, and you set up ST over MP and you got the fraction, I know for sure that that proportion is going to work. We don't have to prove all the other stuff in a triangle as long as we show that two angles in one are congruent to two angles in the other. So let's kind of see this in an example. If we're taking a look at this problem, and they want to know, are these two triangles similar to each other? Like, do we have enough information? Well, we can say for sure that the 45-degree angle is congruent to the 45-degree angle. If we can show that one other set of angles is congruent, that's enough. And we're going to say, you know what? These are similar. They are going to be the same shape, but just different sizes, right? They're going to be in proportion. Here's your second angle. The vertical angles are congruent, and that means that this is true by angle-angle similarity. So we're going to say, yes, they are congruent, okay, by angle-angle similarity, right? We have enough information to say that they are similar, right? And we can kind of look at the same thing here, and we can say, okay, 30 and 70, well, that's 100, which means this actually has to be an 80-degree angle up here to complete this triangle. And I can take a look at this one and say, this is 70 and 85. Well, that's 155, and that means that this one's got to be a 25-degree angle. And so I can take a look at these and say, you know what? I have one angle congruent to one angle, but the other two pairs are not congruent. So I'm going to say, actually, I know for sure that this one is not similar because they are not congruent by angle-angle similarity. So I can throw this one out and say, no, for sure, definitely not congruent. Okay. So here are your other two properties. And these ones are a little bit trickier. So let's make sure that we kind of understand what's going on here. So the first one is saying, if you can show me that two sides of one triangle are proportional, but not necessarily the third, right? We're going to kind of ignore the third side. In this case, they're ignoring BC and RS. We don't know anything about those. But we know that if you set up AB and RQ in a fraction, and we set up AC and QS in a fraction, those fractions represent the same ratio, right? That my proportion is true. And in addition to that, we're also saying that the angle that's in between these are equal to each other in both of the triangles, then it's similar. So this is what we call side angle side similarity. So we're not trying to show now that the sides are congruent. We're trying to show that the sides are proportional and the angle in between those sides is congruent. Okay? And then we have another one that's similar to something that you've seen for congruent triangles. If you can show without ever looking at any of the angles that the three sets of sides are proportional, then that's enough. We don't even need to look at the angles as long as we know that all three sets of sides are similar to each other, right? So it allows us to remove some of the things that we would need to show. In this case, I don't need to show this third side, or I don't need to worry about these bottom angles. And in this one, I don't need to worry about any of the angles at all. I'm just going to show the three sides, right? So let's take a look at maybe an example of this, okay? So if I take a look at this problem, I'm saying, okay, are these triangles similar? Well, I don't know anything about the angles, so I can't use the definition of similarity. The definition has said all the angles should be congruent, so I can't really use that. But since these are triangles, we have some shortcuts. And one of the shortcuts says, if you can show me that the three sides in one are proportional to the three sides in the other, then that would be enough. So here's the way I'm going to start. I'm going to say smallest side is 6, and in this one the smallest side is 9. So I'm going to set up small over big, 6 over 9. Okay? I'm going to do the same thing. I'm going to say here's my middle side, and my middle side, that is 8 over 12. Okay? My large side over my large side, that is 10 over 15. And so now I'm going to reduce these fractions. This is 2/3, right? If I divide the top and the bottom by 3, looks like I get 2/3. In this one, I'd have to divide the top and the bottom by 4, and I'd get 2/3. And in this one, I'd have to multiply the top and the bottom by 5, and I would get 2/3. And so if you notice, the ratios of all three sides are 2 to 3. 2 inches of one, or 2 units of one, is the same as 3 units of the other one. And it's the same for all of the sides. So I can say in this case, yes. Okay? These are similar because of side, side, side similarity. And then it asks us to write the similarity statement. So I'm just going to say, let's name the first one triangle STU. Okay? And again, I'm just going to see how I name this one. I went small side, medium side, big side. So when I do this one, I'm going to do the same thing. Small side, medium side, big side. I'm going to say this is similar to triangle XVW, and that would be enough to show that these are similar by side, side, side similarity.